Hey guys, welcome back. We were dealing with the naming of organic compounds, and here we have done the alkyl radicals. What are alkyl radicals? We are just saying this thing that alkyl is basically formed by subtracting one hydrogen atom from respective alkane. So, an alkane minus one hydrogen will give you the respective alkyl. When we were dealing with the naming, we should know this thing that we have to select the longest carbon atom chain, having smallest number to the branches, having smallest number to the carbon atoms which are not part of the direct counting. Okay, so I am just leading you towards the same concept. We are now practicing some of more examples regarding alkanes so that you people may have a more focused idea about the naming. Okay, just look at here over this compound. So this is like this, for example. Now this has one carbon over here, and this has one carbon over here, and this has one carbon over here. Okay, I am not writing the hydrogen atoms, but definitely I am repeating my words again and again that you people are supposed to write the hydrogen atoms always. If examiner is asking you to write down one of the organic compound, either an alkane or any of the compound, and if you will miss any of the hydrogen, examiner has 100% right to deduct the marks. Okay, so please be careful. That will be considered as wrong. So make sure that you are writing all the hydrogens. I'm repeating my words that always carbon atom has to make four bonds, hydrogen has to make one bond, all the halogens have to make only one bond, whereas oxygen is going to make two bonds, nitrogen is going to make three bonds. So this is so on and so on. Phosphorus is going to make three bonds, but mostly we will deal with carbon, hydrogen, or you may say oxygen, mostly in writing these organic compounds. But no doubt halogens will be there whenever we are dealing with substitution reaction, whenever we are going to make halogenoalkanes or any compound having halogen, and it is organic as well. So you people should know this thing that a halogen cannot make more than one bond, whichsoever halogen it is. Okay, let's see what is the name of this hydrocarbon now. Okay, so it is 1, 2, 3, 4, 5. Okay, if we are doing this pattern, it will be 1, 2, 3, 4, 5. Okay, but it is going continue further. It is 1, 2, 3, 4, 5, 6. You may say. Okay, one more thing we can do is this. Okay, so for example, okay, all right, and then one more thing which we can do is this. Okay, so it will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3. Okay, 1, 2, 3, 4. Done. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. Okay, so the longest carbon atom chain is 1, 2, 3, 4, 5, 6, and there are four branches, two branches on the same carbon atom. So what will be the name of these all? We are going to look into it. Okay, it will be 3, 3, 4, 4 dash tetramethyl hexane. So this is how it is, because at position number 3, this is position number 1, this is position number 2, this is position number 3, this is position number 4, position number 5, and position number 6. At position number 3, there is one carbon at the top. At position number 3, there is one carbon at the bottom. So both of them are at the same carbon atom. At position number 4, there are two branches, one at the top and one at the bottom. So they are same. So at position number 3, the topmost carbon atom, that is made up of one carbon atom chain only, one carbon atom branch only. So this will be methyl. As there are four one carbon atom branches, so all of them will be considered as methyl. So hence there are total four methyls in this compound. When we are talking about isomerism, initially we have started this topic from the start of the isomerism. Here I have just told you the rules for the naming of the organic compounds. Here I am just telling you that while taking the consideration related to isomerism, a student should know this thing that in case of an isomer, basically we have to look into the different structural formula. if we will know what is the name of different compounds, if we will know this thing, how to write down the name of the different organic compounds, then we will get to know this fact that these compounds are isomers of each other, yes or no. Let's have few practices further so that you people may have a better idea. Let's look at this right now. So for example, this is a compound which is written, which I am writing here. For example, this is a compound. This is a 5 carbon atom chain. I have told you that this is a 5 carbon atom chain as well. But in this case, the A has no branch, whereas B has a branch. So B will have a different name. But both of them have same number of carbon atom. It means that their molecular formula will be same, but their structural formula will be different. If we are talking about C compound, look at here right now, it is 5 carbon atom chain again. But in this case, there are 2 carbon atoms at position number 2, one at the top and one at the bottom. So we will say what will be the formula for A? It will be C5H12. Where are H12? It means 3 hydrogens here, 2 hydrogens here, 2 here, 2 here, and 3 here. What is the molecular formula for B? It will be C5H12. CH3, CH, CH3, CH2, and CH3. Whereas, what about the C? It would be also C5H12. CH3, 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 and CH3. So here we can say that all of them have same molecular formula but different structural arrangement. This is the detail about this type of isomerism. If we are going to change the board, we can see this thing that there is another example. We can see 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, and now there is a branch at 1 carbon. There is another branch 1, 2, 3, 4, 5, and there is a branch and another carbon. Okay. So we can say 1, 2, 3, 4, and there are 2 branches at 1 carbon. So what will be the name of number 1? It will be N dash hexane. Why N dash hexane? Because this is a 6 carbon atom chain. N means all of them are connected with separate single covalent bond, and N means that there is no branch. What is the formula for the number 1? It will be C6H14. Same for this C6H14. Same for this C6H14. And this is also C6H14. Here I am writing the hydrogens as well so that those students who still are not getting this thing, they should know this thing that each of the carbon atom has to make 4 bonds always. So if it is going to make 3 bonds, then it will be attaching with one more hydrogen atom. That's it. Okay. Here it is going to make two hydrogen bonds, and this is the 3. This will be 3. This is 2. This is 1. This is 3. This is 2, and this is 3. So this is 3. This is this. Look, guys, this is not going to attach with any of the hydrogen atom. Why it is so? Because it has already made 3 bonds, 4 bonds. So it is not going to make more bonds. Okay, it has no more capacity to make more bonds because it has already made 4 bonds with 4 of the carbon atoms separately. Okay. So how many hydrogens over there? 3 here, 3 here, 3 here, 2, and here 3. But all of them are C6H14. This is the basic target about which you should know that how they are going to make the simple separate covalent bonds and how it is happening. This is the basic concept related to this. So all of these are isomers of hexane. These are isomers of pentane. So pentanes mean 5 carbon atom chain. All of the 5 carbon atoms are connected with each other through separate single covalent bond. Guys, this is also an isomer of pentane because although this is not no more a pentane, but this has 5 carbon atoms, so that's why it would be considered as pentane. I mean to say the 5 carbon atom thingy. Now what will be the name of A? It will be called as N dash pentane. Whereas what will be the name of number 2? It will be called as 2 dash methyl 2 dash methyl butane. Okay, and what about the number C? It will be 2 comma 2 dash dimethyl 2 comma 2 dash dimethyl propane. Here there is lesser space, so that's why I'm just writing over there. Otherwise, you are going to write in the same line 2 comma 2 dash dimethyl propane. So all of these three have different names, but all of them three have same molecular formula, same number of carbon atoms and same number of hydrogen atoms. That's why it would be considered as isomers of each other. That's why these would be considered as isomers of each other. So this is the basic concept related to isomerism. Okay, in case of isomerism, guys, one thing that their chemical properties are different from each other and their physical properties are different from each other as well. Chemical properties means their chemical reactions, they will be different from each other. When they are going to make different type of branches, obviously their reactivity will be affected. How it is going to be affected, it is not part of your syllabus, so that's why we are not going to go into the depth of whole this concept. But right now I'm just letting you know that their chemical properties will be different from each other. Well, when we are talking about the physical properties, that is melting point, boiling point, density, you may say solubility, electrical conductivity, etc., etc. So all of them are different as well. When they are going to make different type of branches, obviously they will have different type of bonding with each other, different type of connectivity order with each other. As a result, they can show different melting points and boiling point values as well. So overall, when we were talking about the concept of isotopes, we have said this thing that in case of isotopes, the chemical properties are similar, whereas physical properties are different. Because in case of isotopes, the atomic number, the electron number remains unchanged, whereas the mass number is getting changed due to the change in the number of neutrons. This I'm just giving you an idea or a vision from that concept of isotopes and isomers, so that you people may not get confused. In case of isotopes, chemical properties are same, physical properties are different. In case of isomers, their physical and chemical, both the properties are different from each other. So this is the basic concept about isomerism. When I will solve the past paper questions with you people, then you can get more idea about that. Inshallah, in the next class, I'm going to discuss the concept about alkenes. Guys, here I have discussed few of the properties of the alkanes with you already. For example, naming, and along with that, isomerism is finished. Along with that, alkenes properties are completed as well. I will discuss the naming of alkenes in the coming lecture, inshallah. Take care of yourself.